I guess I already knew that, but it's a reminder. Properties of these particles whenever known characters of nuclear forces were they that they shall met. Okay. Yukawa suggested that the forces between neutrons also have a field of time. And he was able to deduce the properties of these particles from the already known characteristics of nuclear force. A muon. I don't know who Yukawa is. Okay, I see. Electrical interaction. Could be some other program. Where was that from? Nuclear forces. Different have mass to return time. It's kind of an electron. Hmm. Okay. Mm. Okay. So, by elementary particles, does it refer to like subparticles of like electrons and protons?
Not only that, quarks and leptons and everything like that.
So, is it referring to smaller particles of?
Yeah, this
Okay.
is basically referring to the composition of
So
those
they're just
known particles.
Okay, so known particles. All right, so they can be unrelated to the atom.
And basically every one of them is related to the atom. It's just that, for example, what do you need to create a neutron or a proton? So the elementary particles tell you.
Okay, I see.
It's like a recipe.
Okay, understood. Just like
Yeah,
how,
you're
for
gonna see in the
example,
chart.
the amount of protons can give you a specific atom, the amount of
Mm-hmm.
X elementary particles can give you a proton or something else.
Yep.
Okay, I see.
Yeah, so basically they're gonna be seeing it in the chart that it refers to each of the particles by their mass, charge, and strangeness. The strangest numbers is gonna be explained when they start talking about quantum theory later in the book, but it's interesting
I mean,
to know that they named
I'm,
them strangeness.
I'm a long couple of like years before I get to quantum mechanics, but that's a solid thing. Okay, all right, I see. That's pretty cool though.
Yeah. The interesting part of that specific topic is that they are trying to do the same they do with elements with the periodic table. Do it with the same with the elementary particles,
Trying to
but
like
it's difficult.
categorize them, but it seems to be that seems a little complicated to me.
Yeah.
Especially since I'm in a point of ignorance where I can't really suggest or know anything about these particles. Okay, I see. But I can. But I suppose the strangeness number. What does the strangeness number even measure?
I don't even know.
Fair
It's
game.
like they use it in a similar manner as the columns in the periodic table. That's all I got from it.
Oh, I see.
So if they have the same strangeness numbers, they interact in the same manner with other matter. So
Okay.
yeah, that's why electrons and neutrinos, which are at the bottom of the chart, have their own categories because they interact with matter differently than the other ones. Especially neutrinos that don't have. I don't think neutrinos have mass. They have zero mass.
Neutrinos? Right. They're zero mass.
Oh, and something you have to like get accustomed to is measuring mass as an electron volts.
Oh god. Well, but I don't have to worry about that yet, because right now we're
For
just
now.
getting introduced to physics. I don't need to do any math
Yeah.
yet. Mm, okay. I already read this. Large number of extra particles were found. 30 particles. Okay. What nature wants to afford connections from one another. So basically, we've just been finding particles, but we don't know what they do and kind of how they play a role within our current knowledge of theoretical physics.
Yeah.
Okay.
And it starts getting even weirder when you start involving relativity.
Mm, okay, this seems like a good analogy. Let me read it again. There suddenly appeared a relationship among these elements that was unexpected, and which is embodied in the periodic table of Mendeleev. For example, sodium and potassium are about the same in their chemical properties and are found in the same column in the Mendeleev chart. We have been seeking a Mendeleev type chart for the new particles. One such chart of the new particles was made independently by, okay. The basis of their classification is a number, new number like the electric charge, which can be assigned to each particle. Hey, how you doing? Nice to see you over here. No, I graduated actually. I graduated in a bachelor's in engineering, but I kind of want to reinforce my. Oh, cool. From Romania. That's crazy. I'm from Florida right now. I'm actually from Puerto Rico, but I moved over here recently. And I kind of wanted to reinforce my physics, and I kind of got interested in reading the Feynman lectures on physics because it seems pretty robust. What about you? Are you in college? Strangeness. This number is conserved like the electric charge in reactions which take place by nuclear forces. Do you understand spatial dimensions? Oh, you finished musical school. That's. What do you mean by spatial dimensions?
X, Y, and Z.
You referring to the coordinate system? X, Y, and Z?
Yep. Yeah, because
Oh, 32 years old but jobless? That is wild. I mean, I also practice some music. I practice the piano. How many types of dimensions? Well, why science says that there are more than 3 dimensions? I guess it depends on how you look at it. Because. Nice. It's pretty cool. Spatial dimensions. I don't think that. Where did you read that science says that there's more than 3 dimensions? Is a vector and a dimension the same thing?
nope.
A vector is a line that is a direction and a coordinate the same thing. No, they're not the same thing. So so a vector, how we define a vector, for example, let's say we have like 3D spacetime, right? So it should be, let's say this is X, this is Y, and this is Z, right? So a coordinate would just be a point in space, and it would be defined by, let's say, uh, something like this, right? Right, so this would be a point in space. And there's a difference between a vector. Oh, I deleted it. Right, so that's a point in space. That's something floating in space. You make a point in a circle. Wait, but let me get to it. Let me get to it. So that's a point in space, right? A vector. The difference of a vector is that a vector needs a beginning and an end. So a vector needs some place to start. So let's say that I start from here. A vector will determine the direction. So a vector would be the difference between these 2 points, right? A vector will be defined as the difference between coordinate x1, y1, z1
I think that presents
minus x2, y2,
we're not used to seeing
z2.
C in the vertical dimension.
Since when z becomes vanishing point in an image. I don't think I'm quite grasping what you're trying to say.
No, I get what he's trying to say
What is
though.
saying?
He's trying to like understand why are you using C in the vertical dimension? Because if I'm not mistaken, he's
Oh,
not
at
quite
what
fond
point
C
left
in 3
becomes right?
dimensions.
Oh, okay. At what point left becomes right and up becomes down? Well, I guess. I mean, if you have this, right? After 0, I guess that's why we define negative numbers, right? So when a number is negative, no matter how small it is, it becomes down or right, depending on your convention. So after 0. And it all depends on which point you're standing and looking at it, right? So that's why you establish references. So it's really all about perception. What does a degree in a circle represent? A degree in a circle. It's much easier to look at degrees, so that you understand what degrees represent. It's much easier to look at degrees as radians. A vector can be defined with a degree. Oh, you're asking a lot of questions. I don't mind that though. They're too fast, man. You gotta let me answer one, you know? Could say a circle has 360 dimensions? No, because dimensions would represent a degree is a measurement in a single dimension. So a circle does not have 360 dimensions. It has a single dimension that can be measured, because you should see dimensions as degrees of freedom. Yeah, I understand what you're trying to say. So let's say you have this, right? Look at it this way. All right, before you ask me something else that kind of sidetracks me. So look at it this way, right? I'm gonna make a circle. Let me use a shape.
I think it's better if you first like draw what a point is on 2 dimensions and then move above a level.
A dimension, a spatial dimension, is defined by how many degrees of freedom do you need to measure it, right? So a 2D object requires 2 degrees of freedom to measure it. Sure, if we name this as a C, oh, okay, Z, and let's just call it ZX, right? Right. So how many measurements do you need to find a point in a circle? So you would need 2, right? I add something. I don't know. You would need 2 points. And the way that you define those points, is by how many measurements. Well, you can use different measurements. You could find the x, you could find the y. If you draw 360 straight lines from the center, you have all possible coordinates. Not exactly, because there are infinite possibilities in terms of coordinates, because you will have half angles, right? You can have a 0.5 degree line. So there's infinite amounts of coordinates within a circle, because the real numbers can be subdivided in decimals. So that's why you shouldn't see each degree as a different dimension. It's only a measurement, right? And really a dimension, the degree of a dimension depends directly on the degrees of freedom that the systems need, that you need to measure. In this case, yes, rotation, well, rotation can go on indefinitely, because then all you would do is add a multiplier of the amount of rotations that you're doing. But in the sense that you can only go around, yeah, I mean, degrees are just a convention, and we use 360 degrees because it was convenient, but I do not recall why. All right. So for example, so you should see a dimension. You should see a dimension as how many things do I need to measure? Hyperbolic? Well, I don't know. That's still out of my knowledge. Haven't gone that far yet. But you should see a dimension as how many measurements do I need to take to find a property about this, or yeah, a property sounds about right. So in this case, a 2D dimension requires 2 coordinates, right? A 3D dimension requires 3 coordinates. A 4D space should require 4 coordinates, and so on and so forth. But then, for example, in our perception, like, we can only see... Oh, I'm trying my best, man. Don't worry about it. Hopefully it's been helpful. So how many things do I need to measure to find a point in space? And if it's 2, then it's a 2D dimension. So in physics, we say that we might have 4 dimensions, and one of them is spatial, because a lot of things that occur in physics also depend on time. So for example, motion, right? The way that we study motion, let me put it M, it has 4 parameters, right? So we have the space that it's on, and also we like to measure at what time did it get there. So we have a 4-dimensional space because we use 4 measurements to get there. Well, 3-dimensional space, but in time, at a point in time. So that's why physics sometimes argue that there's more than, that we live in a 3-dimensional space that is dependent on time. Oh, you mean the tesseract? Right. So in that case, then you're talking about spatial dimensions would be more...
Yeah, but in that case, a tesseract is just a 3D representation of what a 4D cube would look like.
Right? Yeah. So you can visualize you can visualize a tesseract as a cube moving in space.
Mm-hmm.
And I went on that deep and a long time ago, actually. I was very interested in that topic quite some time ago. Um, so yeah, there's ways to see four dimensional, like higher dimensional shapes with three-dimensional tricks, I guess you could call them, because it's impossible for us to see a four-dimensional figure. But there's a couple of nice things that I could refer you to. You could also look at Klein bottles. Klein bottles are a 3D representation. Movement equals, I would say, or to be more precise, right? Movement equals displacement in space, right? Movement equals displacement in space. And don't worry about it, I don't need no promo. Oh, no, haven't gotten there yet. Haven't gotten the spinners yet. But I'll definitely, when I hear about those, I'll let you know. I'm gonna go right ahead and keep studying here, alright? I gotta finish this little section. So right now what we're discussing is we're doing an introduction of where physics how did physics start and where is it currently. So chapter 1, just to kind of, oh, here it is. So chapter 1 was basically about the atomic theory. Basically explaining a whole bunch of consequences that happened due to the establishment of the atomic theory. And some processes that occur that we were able to explain due to it. And then in the second chapter, we discuss, how kind of like fundamental ideas of physics came to life. Physics before 1920. But you see, yeah, we actually discussed that. The general picture looked like something like this. The universe operates in a three-dimensional space of geometry, and it also operates through a medium called time. Particles are the elements, and they have certain properties like inertia, forces. We talk about those things in a conceptual level. We're still not doing any mathematics yet. We understand that the law of gravitation exists, but we don't know why it actually works, right? We don't know what drives gravitation. We just know it's a phenomenon that we can measure. Then we start asking new questions like what kinds of particles, what are the short forces that keep particles together. We discover electrical forces, and then we talk about what a field is, electrical field. We talk about magnetic forces. And now we're kind of like heading into the realm of quantum physics, where we discovered that waves behave in an unwave-like fashion at higher frequencies. So for example, gamma rays and X-rays, well, I would say gamma rays and above, behave like particles because their wavelength, and I kind of, yes, I've heard about chaos theory. It's basically the study of randomness to a degree. More like cause and effect study. I took a class on that to a degree. Well, more or less. I didn't completely finish the course. Well, actually, we both did, right, Jorge?
Yeah.
We both did. Oh
That was
man,
a weird class, but
that was crazy. Oh, that was.
I mean,
Well, but I
would-
don't think we actually got to like the deep end of chaos theory, because we spent.
So if I can make a summary of chaos theory, I would say is the study of small perturbations on the outcome of the system.
Right. So you have a system, and if you do something small to it, you kind of study all of the possible outcomes that it might have. So that's kind of where you get into bifurcations, right?
I guess the simplest example is the double pendulum, that if you move the initial conditions to just a small degree changes the outcome a lot.
Right, right. Yeah, because that's kind of why you learned about what was it? The initial part of it was finding out the nodes, right? The different nodes of the system.
Stationary points, I guess.
The stationary points, right? In which would those stationary points would tell you that depending on which initial condition you have, the system might behave differently,
Mhm.
right? Yeah. So that's kind of where chaos theory falls in, because when you have like systems that depend on variables within the same system, the stationary points can kind of just do whatever the hell they want. That's a fun one. It would be nice to revisit that. I
I
don't
was planning on looking into it in the future
I
because
still have the book.
I guess we omitted the most important part of that
Yeah,
class,
we
which was chaos theory.
we just didn't get to the end. It's such
We were
a
just drawing graphs one on top of the other.
oh man, that was crazy. Have you seen the movie Hellraiser? No, I haven't.
Always.
What's it about?
I think that's why he mentioned the Tesseract because I guess there's a Tesseract involved in that movie.
Oh, I see. Okay. Nuclei and particles are the elemental forces. Okay, cool. Okay, so let's finish this little section. See what this is about. Table 2 listed particles. We cannot discuss them much at this stage. Underneath each particle is mass given. What was boring? The movie? I mean, try your best to explain it to me. You got this. I believe in you.
Yeah, I know understood. It would be nice to have a summary of them.
The reason this unit was chosen is historical. Oh, the MAV. Oh, okay. Mass electron volts. Is this where you say that we have to start turning mass into electron volts?
Yeah.
Fun. It is a horror movie from the 80s that had God represented as an octahedron. Why exactly as an octahedron though? That's crazy. That's a very specific shape, not gonna lie.
I mean, I think there's an episode in Rick and Morty that refers to the movie Hellraiser. You know that episode that Jerry is treated like a god to some people that like torture.
Man, I've
That they
seen
have
Rick and Morty,
piercing
but
their
I genuinely
nipples
do
and
not
stuff.
remember that episode. What episode is it? I mean, you're already explaining it to me. I just don't remember it. What season is it from?
I don't know if it's season 3 or 2. I don't remember. Let me see if I can find it. But basically, it's like they love so much torture that everything that is considered pain is good for them. So it's like the inverse of us.
Oh, okay. Yeah, I think I remember that one, but it's been such a long time since I watched Rick and Morty. Part of the Platonic solids, crystal field theory talks about degrees of freedom. Crystal field theory. That should be something to look into. Yeah, just imagine degrees of freedom as, because it's important to sometimes, because what I might see is that like you have isolated knowledge in specific subjects, right? So to tie things together, sometimes it's good to be very, what I would say, consistent with the definition. And I would define a degree of freedom as, you know, I guess the only way that I define degrees of freedom is through an analogy, right? Again, if I have a point in space, how many measurements do I need to take to find that point, right? A lot of people also use degrees of freedom as the ways in that you can move, right? So I can move forward, that would be, you know, upwards and downwards would be one direction, right and left would be another direction, up and down would be another direction. So those would be 3 degrees of freedom. And this, I guess you could even add. Well, I guess if you lock all of those, I can't rotate, right? So yeah.
I mean, it would be a total of 6 degrees
In
of
that
freedom
case, it would be six
we,
degrees of freedom, right? 6 degrees of freedom because I
because
can move in
if we
six
consider
directions.
rotation.
Yeah, but if you lock all the 6 degrees of freedom, then you don't get to rotate.
You know that something that blows my mind is like, you know that each time you add a spatial dimension, you add a rotation with respect to the axis, right?
That makes sense.
So what happens if we were a being that could travel in the fourth dimension in time? Would there be a rotation?
Bro.
It's something trippy, but a question I
Space
always
rotation.
had
What would
when
time
they
rotation?
start talking about degrees of freedom.
Bro, this sounds like this sounds like some weed brownie conversation type shit.
That sounds like a Rick and Morty conversation
That's like
right
time
there.
rotation, dog. Give me some time rotation.
Because we do travel in time, but only being prisoners of the present.
So time rotation would be like a loop. Imagine that. You'd just be reliving the same event and then it would end and then you would restart.
Huh.
But you would
What
not be,
happens then if
but in that case, since we're beings that depend on time, we wouldn't be aware that we're looping.
Yeah, but the thing is, like, which is the reference axis in that case? Because
Bro, you.
I know that I'm rotating.
I gotta give you some
60
shrooms,
degrees.
dog. I'm telling you, you're gonna figure it out on some shrooms. If somebody's gonna figure it out, it's you on shrooms, dog. Not me.
Oh, he mentioned that if you have heard Lorentz transformations.
Lorentz transformations. Probably heard about it. Let me see. Lorentz transformations.
Just in case you're wondering, those are the transformations that they start doing in special relativity.
Oh, I see. Wait.
Yeah, and they are hyperbolic transformations.
So they basically turn the space-time curve into a hyperbolic
Yeah.
function.
Yeah, so practically what special relativity always mentions is that if you're not moving, you can see your spatial dimensions as a square or a cube, but when you start moving, especially at a fraction of the speed of light, you're gonna
But
see
how much?
things
But how much?
transfer.
How much of a fraction?
Let's say
But
point
does it have to be
eight?
a relevant fraction? Like if I start moving right now at my scale, am I gonna do that? That's why you can probably omit it, right?
Yeah, you're not gonna measure it
And
unless you start moving like a 0.3 fraction of the speed of light.
that makes
something
sense.
like that.
Yeah, right. Because if I move, like I can't move that fast. But I suppose that Lorentz transformations are used more for like, what is it? Universal scale stuff.
Yeah.
Okay.
I mean, everything astronomical has to be measured
Astronomical
at scale
stuff.
because of the
Yeah, because they move so
size and
fast
the
and
speed of
they're so
things.
big as
Mhm.
well. Yeah, that makes sense.
Yeah. If you zoom in on the top equations, those are the basic Lorentz transformation equations, and gamma is just the Lorentz factor. which
Okay, is
considers
it constant?
the fraction?
Oh, here it is. This.
It's not a constant because it's a factor of how much you're moving with respect the speed of light.
Oh, okay. Okay, so is
So
it like
if
how much you're
you
moving with respect to
yeah
the speed of light? So what do you mean with respect to?
because everything is relative, Stella.
I understand
Think
that.
about
I
it.
mean, I know. Like, if you're standing in a different position, you're gonna, as an observer, you're gonna see something different. But like, what do you mean by
Exactly.
in relation to?
So if you're right here on Earth, right, and I travel into space with a rocket, if you could measure my speed with respect of your position on Earth, that would be my v.
Okay.
with respect to you, but because from my perspective, you're the one who's moving, not me.
That makes sense. Okay, now I understand. I understand. Okay.
So we would be having the same v in magnitude, but the direction is different.
Right. Exactly. There's a different direction. That's best. It should be the same magnitude. So
Huh.
how would you relate it to the speed of light though? Like how do you measure relating to the speed of light? Because I guess
Well, the speed of light is a constant, and you know your velocity, so you consider the Lorentz factor, and it gives you this factor that I think is greater than 1,
right. Should be.
if I'm not
Because
mistaken.
if not, then it would just everything would be 0.
Yeah. So that's why if you see the top equation where you have t prime,
Yeah.
that's the famous equation for time dilation.
Oh, I see.
If you're here on Earth,
because light takes longer to get to you.
yeah. So
Okay.
if you're here on Earth and I'm moving at 0.5 the speed of light on the rocket, you can use that formula to calculate how much of the time I'm gonna be spending up there with relation to you. So, in other words, you're gonna measure a time dilation while I'm gonna measure a normal time from my perspective.
And your perspective would be which one?
If
From Earth?
you consider okay, you have to first consider a rest reference. So your
That's
rest
that's
reference
what I'm
gonna be
asking.
your
Like what
perspective.
would be your reference?
So I would say here on Earth,
Okay.
and the moving order would be my rocket, right?
Right.
So if you're right here and you want to measure t prime after t time passes for you,
Yeah.
you can calculate how much time actually I have experimented on.
Oh, okay. Okay, I see.
That's why it's called time dilation, because if you have seen the movie Interstellar, that's a big example of extreme time dilation.
Yeah. Since they were so close to a black hole, space-time is so curved that they experience time super differently. So then when they go back, they're like, "Oh, why are you so
Yeah.
old?" Time dilation. Got it.
Yeah, and that's the interesting part of Lorentz transformation is that at that precise moment in special relativity, you're not considering gravity. You're just seeing everything from the perspective of kinematics first.
That's interesting. That's also something that I was gonna ask. Does that come in general relativity? Is gravity taken into consideration in general relativity?
Yes, that's what makes general relativity so important. Like general relativity is when you consider special relativity with gravity. And that's where you find out that special relativity is a special case of general relativity.
Right. Special relativity seems like the idealized case.
Yeah. You remember in physics when you try learning kinematics or a constant acceleration and then they teach you what a force is? That's basically what happens in relativity.
Okay.
Special relativity is kinematics, and when you talk about general relativity, you start talking about forces and all that.
Oh, okay. I see what you're saying. So you ask a bunch of questions. Let's see. Why does the image curves in 4-point visual perspectives? I don't know what that means.
So you're referring to that image of the Earth bending.
This one here? The Earth image?
Yeah.
So why does it bend? Well,
I mean, it's just a representation of what we think gravity does.
So, because the problem is that at first, so I will give you like a little bit of a history lesson. So at first, because theories try to explain things that we're experiencing, right? So at first, the only thing that we saw about gravity is that it pointed downwards, because we didn't have like big scale stuff to analyze. Like we didn't analyze planets at the time. So, we saw that. Which 1 to 6? Right, give me a second though, because I gotta finish this chapter. Image curves in 4 point. Anyways, so visual point. I guess the only way I'll be able. What is the difference between a point perspective and a spatial dimension? All right. Before I answer any questions, try to define me what you feel like a space dimension is, because it's important that you have some definitions static so that we don't keep changing them across the course of the conversation, right? So if you are going to ask me what a spatial dimension and a point perspective is, you should have an idea of what a spatial dimension is, right? I don't know what a point perspective is, so that's why I'm asking specifically for a spatial dimension, so that I can answer referencing to your definition of a spatial dimension. Does that make any sense? So type in the chat, what do you define a spatial dimension to be? I'll search the point perspectives. Direction you can go from where you're at. Okay, so you're defining, let me see if I can use more.
So he's defining spatial dimensions.
Spatial dimension for me is a degree of freedom. Okay, so degrees of freedom talk about motion, right? So degrees of freedom are a little bit different from spatial dimensions, right? A dimension is like a direction in which you can measure, right? A degree of freedom is in how many directions can you move, right? So let's imagine. So there's a big difference between the two, right? Because, for example, in an axis like this, the love axis, you can measure technically 3 dimensions. Because you can measure this dimension, and this dimension, right? You say infinite. You could look at it as a sandwich. That's one way to look at dimensions, right? You could look at it as a sandwich. Yeah, like a line can technically be defined as a bunch of small points put together. And obviously you're going to need an infinite amount of points to fill out and make a line. So you could look at it that way, right? A 4D plane is where movement is allowed. Right, because technically what you're doing, it's not that movement is allowed, is that to view 4D, movement will need to happen because we live in 3D, right? So look at it this way. Give me a moment. So let's say you have so this is a line, right? And a line, still a line is like one dimensional, right? But I guess in relation to the point, a line can be 2-dimensional. Interesting. Into visual point perspective. Wait, you're going so fast, dude. I have to put thoughts together, and you got all these questions ready for me, man. You gotta give me a second. Can't do this to me.
The important thing is curious to know.
All right, so. Anyway, so degrees of freedom. Degrees of freedom, I already defined dimensions, right? It's which direction can you measure. Degrees of freedom is in how many directions can you move. So you can move up, here, 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 and here. If you connect all 3D axes. Right. Yeah, no, I understand. Yeah, all this is making sense. Now but you see why it's important to define stuff, because we're gonna get to the same concepts together, but we gotta keep coherence, because if not, then we're just gonna be all over the place. Okay, so degrees of freedom, in the terms of like movement directions, right, is how many directions can you move? So 1, 2, 3, 4, 5, 6. You can move in 6 directions. So let's talk about a cube for a second. Or actually, let's talk about a cylinder. Just for simplicity's sake, because a cylinder is a little bit more simple than a sphere. Okay. Wait. Just to clear something up. Because there's also other types of motion. So let's say I put a wall here, a wall on the back. Let me try to make them. Okay. I put another wall here. I put a wall on the bottom. And how many directions can this cylinder move? So if we take a look at our octahedron, I'm going to call it an octahedron so we speak the same language, right? So we can't go down, so we take that off. We can move in these directions because we don't have a wall on the backside, right? We only have what we can't move here and we can't move here. So we have 3 degrees of freedom left. If I put a cap on it, for example, right? I put a cap on it, now we can't move here. If I pull a wall in front of it, I'm just gonna represent that as this. I put a wall in front of it and I put a wall on the back side of it as well. We can no longer move here. But what can the cylinder do still? There's still a motion that the cylinder can do. What do you think it is? Imagine that this is a cylinder, right? The cylinder can still do this. It can rotate. So technically a cylinder has 7 degrees of freedom. Yep. There it is. Right? So degrees of freedom are heavily dependent on the system that you're talking about. But in 3D space, there is a total of 9 degrees of freedom. Because there's 3 axes. So a sphere, for example, I don't know how to draw a sphere in 2D plane, but a sphere would have 9 degrees of freedom. That if you wanted to make the sphere stationary, you would have to find ways to remove all of those degrees of freedom so that it doesn't rotate or move. Okay, so degree of freedom is referring to in how many directions can you move. And a spatial dimension is how many measurements do you need to take. That is why we count to 10. I don't think that's the reason why we count to 10. Wait. Again, we have to learn how to connect the dots here. 3 plus 6 plus 0. That sounds like a conspiracy theory, dude. You gotta you gotta be careful here, man. I'm not making fun of you. We're having a good time here, but that sounds like a conspiracy theory. I don't think that's why we count 180 degrees. That seems
That's for his knowledge or her knowledge or their knowledge is that.
That sounds like a conspiracy.
I mean, we have 10 digits.
remember that correlation does not mean causation. I have heard about Nikola Tesla. Correlation does not mean causation. Just because it just so happens that you'll actually find that a lot of things seem like they're causes of one another. It just so happens that a lot of times in nature, things tend to behave very similarly, right? Or things tend to have like some pretty looking patterns, right? But I genuinely believe that one thing does not correlate to one another. It just so happens that our convention works really well with that. Oh, I remember why. What was it? I think I remember why we actually separated the circle in 360 parts. It's because by separating the circle in 360 parts, it made it really simple to find, for example, like the angle of a quarter, uh, the angle of the half of a quarter would perfectly divide the circle in equal parts. So that's why we use 360 degrees. Because if we use 300, for example, we wouldn't find these half circle stuff, right? That's why we did it. That's how. I remember that I taught that to my high school kids when I used to be a high school teacher. That's the reason why we separated the circle in 360 degrees. But anyways, well, I think that, and this might get more into more philosophical. Hey man, I'm doing my best. I'm doing my best. We're all learning here together. I think that although it is conspiracy, and explain one last thing. Okay, man. Hear it in my words. Okay, I'll take that as a compliment. Point perspective. 1 to 6. I mean, we're supposed to be learning about the initials of physics, man. You're diverting me, but it's all good. I am finding some interesting stuff. Oh, I see what you're saying. Four-point perspective. So I guess this is 1 point, this is 1 point. Where's the other points? I guess up here and up here. 5-point perspective, 6-point perspective. How do I explain this? Okay, to me this makes some sense. How many point perspective does the human eye sees? I would definitely argue that this peripheral image sees the image curved. Oh, I see what you're asking. So you're asking about optics now. Optics. That's what your question relates to. Okay. We're talking about optics. So you see why, so it's important, right? That and this has nothing to do with the question that you've asked me. I'm gonna get to that later. But the important things, because like I told you, like you have a lot of like isolated knowledge about some concepts, right? And then you see similarities in concepts. Not that they're unrelated, they are related, right? But when you're able to put a topic on them, like a subject on them, for example, like when I saw this, the first thing that I saw was optics, right? This is related to optics, and that's a chapter that we might get to at some point. I'll give you a moment. So for example, here, look at everything related to physics here. Like this book is amazing. This book teaches you a lot about like how physics works. See, we have geometrical optics. So we might get to stuff like that in chapter 27, which is pretty far away, honestly. No, it still has to do with physics. Yeah, but having isolated knowledge about subjects might cause you to feel like some things could be correlated, when in fact what you might be experiencing is the lack of definitions for specific concepts. So what I'm seeing here, perspective, the human eye, so I mean, I guess if you look at the screen, right? If you look at the screen, if you look at in a practical sense, this is what I would say. In a practical sense, the end result of what we see is definitely a 1-point perspective image. Right? Because, and if you would go about what artists were drawing, right, when they were focusing on drawing images of their landscapes, you could even argue that, you know, 2-point perspective is also a thing that we could do, because when you look at this image, right, a 2-point perspective is basically telling you, hey, we have a point over here, we have a point over here, and to create depth, we just throw out a line, right? Yep. Yeah, so I guess we can kind of switch between 1-point perspective and 2-point perspective, because if it just depends on where we're standing, right, to a degree. 2-point perspective seems very natural. 3-point perspective, as you can see, three-point perspective seems not like something we would be seeing from the human eye. Well, the curvature, okay, so this is how I would see it. This is how I would explain it, right? I'm gonna put a point over here, right? I'm standing over here, and I'm an observer far away. And I want to kind of, let's say I want to draw the reason why it curves is because of the shape that it creates. So for example, in 1-point perspective, let's say we're standing, right? We have this panorama, we have like, say we have this point and we have like buildings over here and stuff. So what we're really doing is like throwing a line, right? That helps us create the feeling of depth. That's like in drawing, right? You're kind of throwing out lines that help us create the feeling of depth. Because I took this class like when I was in 6th grade, so I could do 1-point perspective in drawing, and I was not that bad at it actually. So I could do like lines that gave me the idea that depth is being created. For example, stuff like this, right? Kind of those things kind of just draw away from each other, right? So that's how you create depth. But wait, I gotta slowly build up to it, because I'm also developing this idea in real time. So a 2-point perspective, if I put a point here, I do a line, they kind of converge in the center, right? So a 2-point perspective really is a way to define a line oh my god. A 2-point perspective really is just connecting these two lines, a line in the center, right? But if you treat them separately, then you get the idea of, you know, you have a building that's being divided by the corners. Okay, so let's see the case of 4-point perspective. No, let's do 3-point. So 3-point perspective, if you connect the lines, you create a triangle, right? So, and you start throwing out lines to create depth, for example, and then, you know, when you draw these things, they kind of look like they're falling within the triangle. So that's why the 3rd-point perspective, it kind of looks like it's falling within the triangle. So if I was to draw a building here, right, it would look something like this. like it's falling within the triangle, right? Not a good drawer, but I'm trying to paint the picture. So let's talk about 4-point perspective, right? 4-point perspective. If you put 4 points, right? Why did this automatically draw a heart? Anyways, 4 points. Let's try to make the equidistance, like equidistance, meaning that each point has the same distance. So you draw a line from here to here, from here to here. Oh shit. I am not going to agree to something that I don't quite understand yet. So let's keep doing the thought process. Let's keep doing the thought experiment. Four-point perspective is an octahedron. See how that makes sense? Yeah, I guess I see what you're saying. What you're saying is the shape that it creates. Right, because what you would have is the center point would be here. I guess if I would define it over, there would be 1 point here, 1 point there, and then this would connect to this, and then this would connect to this. Oh god, it's not a very good. And the background is something like that, right? That's why it's an octahedron. And everything will fall within everything will fall within this shape, right? So if you want to draw lines, then you know the curve will start occurring naturally, because the more point perspectives you add, the more you're going to look like a sphere. Does that make any sense? No, you can't make that assumption. You can't extrapolate information. You can't make that distinction. You can't extrapolate information like that. Because this does not relate to our perception of the world. Like, why would you assume that there is no up, down, or left? Because you can. This is a drawing technique. A drawing technique does not relate to the perception of the world. Well, okay, there is no down, left, right. So if you were an observer that could see everything, right? I see where you're heading. I see where you're heading with this. If you're an observer that has the capability, of seeing all directions in a single point, then for you, our directions don't mean anything. But for us, it does mean something, because we can see them and we can experience them, right? So again, like saying that up, right, and left are not real, because if you were a being that could see, for example, like all directions in a single point, I find that odd. I find that as a jump in conclusion. because there's so much missing information. Yeah, but we're not beings that can experience the world like that. So even if that were true, it's not information that we can even use. Do you get what I'm saying? I mean, I understand what you're saying. I really do. Like, I understand the concept of what you're saying. But the way that we define stuff is based on our experience. So what use would it bring us to define stuff on the experience that we don't live, on an experience that we don't perceive? Because technically what you're arguing is that, you know, everything is made up, which in some way it is true, like, but you know, there's definitely there is definitely something there, and I know it. Okay, sure. Could be of something, you know, definitely something there, and I know it. Okay, interesting. Well, I hopefully I answered that in the best way that I could. Well, there is secrets everywhere, man, and that's why, to understand the secrets of things, it is our duty to find the best source of information so that we can uncover more secrets. And that's why I'm doing this, right? I mean, I already studied some physics in college, but I still understand that I don't understand a lot of things. And before I jump into any conclusions, it's important for me to have all the facts straight. Not all the facts, all the things that we currently know, right? Because to know what we don't know, we gotta know what we know, you know? And in both directions. The more you learn about something, the more you realize is that we know very little. And that's the only thing that's true. There's genuinely secrets everywhere. Like if you would follow along my stream every time I'm studying this, you'll see that this book, you know, although it's a physics book, you might believe, oh, these scientists, physicists think that they know everything. No, they don't. They really don't. And in this book, in the introductory chapter, the first thing that they do is present you with all the ideas that we still don't know how they work. And we're okay accepting the fact that we're not aware of how they work. And, you know, the fact that we know where we're standing allows us to explore things further. So that's why it's important to connect all the pieces of information before we extrapolate before we deduce, right, any conclusion about how the universe operates. But to your point perspective subject, I do believe that, you know, if you were a being that was on a scale much bigger than us in terms of how they experience spatial dimensions, because this is really the question that we're talking about spatial dimensions, right? So if there was a being, when I say being, it could, you know, a living being, let's say like a bacteria or whatever, like a super huge being, that an entity, let's call it an entity, because it, you know, a living that is beyond our spatial dimensions is definitely some sort of entity. If there was an entity that could experience the world in a 5-point perspective, right, in a bigger dimension than us, he could definitely see our universe in a single frame, right? We couldn't see it, but we could experience it. We could experience its motion. Just like, for example, if you have a cork in water and then you move the water, then the cork reacts to the motion of the water, right? Yeah, so I suppose, well, there, if you're referring to the geometrical aspect of it, uh sure, just how, for example, a sphere falling, just like for example in a 2D space, if you have a circle, a circle is going to perceive a sphere as a circle growing and then shrinking. Yeah, I understand what you're saying, and I would definitely argue each dimension is wrapped in its own space. I would disagree with that. Each dimension is a bigger group of the other dimension, if you're referring to spatial dimensions. So, for example, if you're in a 3D, you can definitely use 2D and 1D, but you can't go upwards. So you're not trapped. You're more so, I would argue that you're limited to these. And I guess that's what you were trying to say, but I wanted to make the clause that you can use the ones below you. So a 4D species, right, could definitely interact with the 3D space. It's just, it would be in a different manner. Hmm. Why do you, just a small question, why do you feel so, mm, what kind of gets your gears kind of moving relating to this subject? Like what is it that you're trying to find by knowing this? Because I feel like you say a lot, there's something, right? Like there's something there, there's a secret. Um what is it that you're trying to find by learning about this? I feel like through your knowledge of this, there's some outcome that you're tying to it, and I don't know if that's, I don't know if, I just don't know how to feel about that though. What is the outcome that you're trying to get from understanding this information? The truth. You know, truth is tricky. I would never call it the truth. I think that whenever you're trying, Okay, and that's fair. I'm an atheist as well, right? But I'm atheist as well. Like I never had a strong inclination to religion. Same way as science. You see, that's very conspiratory, and I don't think I agree with that. I'm atheist as well, but I don't look at it that way at all. Um, let's see. Sure, there. Why do you need to take such extreme stances? That's a really extreme stance, in my opinion. I think that there's truth in everything. Just because religion and science is used to make more money doesn't make it not true. Both things can be true at the same time. You know, that's I think that as people, sometimes we fall a lot into the trap as in seeing evil in one thing and then extrapolating the entity in its completion of being evil. For example, I'm atheist, but I find value in religion in the sense that religion can. Oh, that is a very important thing to say. I'm actually really proud of you for acknowledging that. That is really cool. So you're at a point where you don't know what to believe. I would say that's the most interesting statement that you've done all day. And the fact that you're aware of that is really cool. That's really nice. So let's talk about that. Well, let me get some points across, and you know, you can let me know whether you agree with me or not, right? So the truth, right? In the best case scenario, I did the best I could, but deep down inside, wait, give me a moment. Let's get into the and that's another great thing to accept, you know. That's another great thing to accept. But this is the problem that I've seen, and especially in people that, you know, I feel like you and I have a similar background in the terms of our spirituality, where, you know, I was raised in a, I wouldn't say particularly very Christian household or you know, religious household, but you know, most of my culture believes in Christianity, right? So even in school, you know, Christianity would be very predominantly the main religion, right? That most people would believe in. And you know, I guess when you're trying to figure out your way into the world, you kind of decide to, you know, use the tool that they're using as well, which in my case would be Christianity. And you say you believe in it because, you know, since everybody else believes in it, then, you know, why would you not, right? And then you get to a point in life where you start questioning stuff, which, you know, I was about the same age as you. I would say I was a little bit younger when I kind of started understanding that I was atheist is sure. I would say atheist. Yeah, definitely. But you see how I don't think there, and that's fine. I think that right. Give me a moment. So I gotta make the whole story. So, um, I was an atheist, right? And when I was younger, I would definitely ask religious people like, why do you believe in it? Like, what good does it do to you, right? Like, there's no point. Like, you know, everything in terms of religious is not true. And I would go into like arguments, trying to understand certain things about it, trying to understand the people that believed in it. Where did the source of their belief come from? And then you kind of start heading into a more scientific direction, right? So cool. You start believing in science, and then you also see all these corporations abusing science to get their needs and meet their monetary goals, right? And then you start saying, well, science is also evil. And this is the problem of reducing everything to a single thing, right? You can't, the same way that you can't extrapolate information based on a small sentence or the same way that you can't extrapolate information based on a single line of information. You can't make a paragraph out of a single line unless it's like fluff, right? You can't extrapolate information like that unless it's a very obvious thing to extrapolate. When we're talking about big groups or big corporations or big entities, there are two sides of a coin, right? The people in power need to keep the religion alive, and the way that you keep stuff alive in today's world is through monetary means, right? So the people in power need money to keep people alive. Scientists need money to keep science alive. How else are they going to sustain themselves? So just because something needs money to function doesn't mean that the goal of the thing is an evil goal. Everybody needs money. I need money. Just because I want money doesn't make me a bad person. Doesn't make me disingenuous, I would say. Not bad, disingenuous, right? So that's why we have to look at the underlying vision of each entity. What are its foundations? And its foundations, I'm not talking about its beginnings. I'm talking about what it stands on, right? So I'm going to use the example, and this is why I am not against religion. I think religion is a good thing for some people, right? I think religion is not a bad thing. And if we talk about what religion did for a lot of society throughout the years, I would argue that it did mostly good. Is it for me? I don't need to use religion, right? It's fine. Like, I don't need that tool, but I view it as a tool that will empower certain type of people that resonate with it. So, and it's similar to science. Some people really don't resonate with science because they feel powerless, that a lot of things are not in control of some other being, right? Some people really resonate with science because they don't care that the world is like that. So they just accept it as it is and are willing to accept those as how the world works. So in religious, and the foundation of religion is quite simple, right? You follow a certain set of rules, which also kind of approves the idea that religion is a tool made for controlling the masses. Do I have a problem with that? No, because the world used to be shit. And if you think the world is shit now, you should definitely try living before, And the world before was much, much worse, and you definitely needed something to make people behave, right? Because there were rules. Actually, people before used to get executed more often, and people still do atrocities, right? So invoking a fear of God upon people was probably really smart. In my opinion, right? That's how I see it. So it seems like a solid way to control the masses, especially at a time where people were highly uneducated and highly volatile in terms of how they reacted to situations. It was a very powerful and smart tool to create, if it was created. I'm assuming that I'm not a religious person. I don't believe it to be real, but it was a smart tool to create, especially for people that needed to control society in order to build a civilization, right? Every big civilization had a big, huge, robust level of religious beliefs. Do you think that that's a coincidence? I don't think so, because in a way their religious beliefs gave them order, and order is really important to create a strong civilization. So there is no, religion is not wrong. It's not bad. It's not inherently bad, right? Um, do some people abuse religion? Sure, sure, of course, yeah. Um, do some people benefit monetarily in terms of religion? Well, yeah, of course. You need those people in order for the corporation to exist, right? Because if not, then it would just go bankrupt and nobody would want to do it. So science is very similar, right? Why do I believe more in science than religion? And this is where I think this is something that I don't know if you know this already, but the scientific method, I believe, is the only method of knowledge acquisition that allows itself to be wrong. Science never claims something to be definitely true. You will never hear an actual scientist or an actual expert tell you this is the truth. An expert will always tell you this is what I currently know, right? And that's the main distinction about science and religious beliefs. Science allows itself to be wrong. There's never going to be one scientist that will would our vision on life change if we knew for a fact that our planet is the only planet with life, and why so? What do you mean except when using statistical facts? Statistical facts are also temporary. Statistical facts could also change, you know? A statistic, and the problem with statistics is that, so a statistic is a set of discrete data points. Yeah? You know, okay, so the cool thing about science is that you get a theoretical model, right? Right, but, well, because remember, the more you know about something, the more you understand its nuances, but you also understand that you also lack the knowledge to understand the nuances. So this is where scientists, through educated conceptions, they will develop theories to try to explain certain behaviors, right? And you know, the other part of science is testing. So sometimes our theoretical knowledge is more advanced than what we're able to measure, because that requires technology, and technology sometimes is behind our creativity. You see what I'm trying to say? But sometimes those theories, although they might not be tested, explain a lot of phenomena consistently, right? So we adopt those theories until our technology catches up and we're able to experiment on it. That shouldn't traumatize you. There was no other way of other civilizations. Well, I don't understand why it did. I mean, to me, it makes sense. There was no other way other civilizations could experience the vastness of the universe the same way that we did. We literally have satellites that can see how far away, you know, the universe is, right? How big the universe is, and even then, we can only see a small fraction of it. So you know, obviously we understand. Oh, my bad. I thought that you. No, I got it backwards. Well, I would argue that the universe is in the center of nothing, right? The universe is the field in which everything exists in. Does that make sense? Look at it as a sheet. The universe is the sheet in which everything lies upon. This is complicated stuff. We cannot discuss them at this stage. Okay, how we do not know. Okay. You see? This first. Well, why do you need to attribute value to your life based on that? This is again, this is extrapolation. If the whole universe is the earth. No, the whole universe isn't the earth. The universe is where everything lies, and earth is a small component on it. And if we're the center of the universe, that wouldn't change anything, because we're still gonna have to live our daily lives. We're still gonna live our, why would that make you feel any other way? Your life is still gonna be your own. You see, like, why, I don't know. How do you gain value to your life? That's subjective, but the way that I gain value to my life, right, is by doing things that I believe add value to it. Yeah, I mean, I understand, but the way that I add value to my life is under my own accord. I don't use external parameters to add value to my life, because that literally is meaningless. Like, why? If my life depended on the existence of a god, or the existence of the fact that the earth is the center of the universe, or if my life depended on, if the value of my life, if I thought that the value of my life depended on any of those things, my life literally does not belong to me. And it removes all sense of accountability that I could have for myself and for what I do on a daily basis. I don't think I'm special, right? So this is the thing. I don't think I'm special. I don't feel the need to feel special. There is no point in feeling special. I just am. And whatever I am, I accept. I am not tied to an outcome, especially outcomes external to me. The only thing that I care about is, well, there's no duality if you accept both, right? Accept both. You are normal. We're all normal. But if you can make yourself feel like you are doing something for yourself, then you won't feel normal. Feel me? It won't. I genuinely don't think it will. It won't destroy us. It will destroy the people that are so tied to a specific belief that they can't fathom the idea of things not being black or white. Then that's Darwinism, man. That's Darwinism. They're not gonna make it. Actually, I disagree. 90% of the planet. I think a lot of people genuinely don't think about these things on a daily basis. A lot of people just live, and that's why the people that think less are the most happy, because they just accept whatever they are. I'm very much a thinker. I am an overthinker about everything, and I've had to tone down the level of depth that I put into some things, because genuinely, when you think about it, you are what you do every day, and that's just how I see things. I just focus on doing something that I feel will enrich my life further. So I just do that. You know, my main goal in life is to simply, if my turn to die is tomorrow, right? I will make sure that I did everything I could to live every day as in under my own accord as much as I could. It's really that simple. So if I die tomorrow, I won't have a single regret because I've done everything that I've ever wanted to do, and I never put any boundaries or obstacles on my own path of figuring stuff out. So if tomorrow the world ends up, you know, the planet ends up being the center of the universe, then it's completely indifferent for me. You know, it really does not matter to me. It's not something that will change my life. It's not something that will change anybody's life. All right, give me a moment because we're supposed to, both of us, be learning this stuff, you see? We're supposed to be reading this. Particles are shown us. Particles shown us online resonance dash one. Particles that are emitted from the tapeworms. The zero mass charge particles. Newer resonances. So on our table. Again, so you answered the first question that I asked as the truth. You want to find about the truth, right? Well, in one way, shape, or form, and I guess I've arrived at this, there is one truth. Because I am a firm believer that there exists one truth, that is, you know, the one truth would be the single line or the single sentence that would explain all about the universe, right? But I also believe that we'll never acquire that one truth. So, asking myself, you know, giving myself the task of finding the truth is basically like swimming underwater without being able to breathe. You know, you're not gonna do it. You're not gonna last very long in terms of, I guess it's a very emotionally draining task. Because there's just so many things that you don't know, and all you're gonna have is always more questions, and you're not gonna accept that because your goal is to find the truth. So, right, exactly. So I think a better outlook is that instead of trying to find the truth, is try to find yourself, right? And in turn, by trying to find yourself, you'll move closer into finding the truth. Because in the process of finding yourself, you'll also find other people. You'll also find other experiences. You'll also find, you shouldn't be tied to this outcome, but you'll also find a certain level of happiness with that. And finding yourself is really hard, because that means asking yourself hard questions like, what do I want? What do I want to do? How am I going to do it? And then actually doing it, right? Which actually doing it can be really scary. Okay. Okay. Let me start writing stuff down. One exercise that I really like to do is this one, and you know, and I exactly, yeah, yep. One exercise that I enjoy doing a lot is this one, right? And I do this
on a, I wouldn't say on a daily basis, but sometimes, right? I look at my current self. Where am I, right? Where am I currently in my life? Where am I? And I feel like maybe I feel like I'm in a very bad place, for example. Uh, and I would retrace all of my steps up to this point in life, right? And I would ask myself, what parts of that, storyline um, influenced the most in me being here? And what was my role in those scenarios? Because again, thinking about what external sources affect your life is as meaningless as reading a book that doesn't have a word, because you can't do anything about that. You really can't. There's really nothing you can do about external sources. But what was your contribution to your current point in life? And that's where it gets tough, because your ego basically needs to die, right? I would actually grab a notebook and start writing stuff down sometimes. Mm. Particles are shown with a solid line. Okay, so this is the solid line. And resonances with dash one. Okay, I see. Okay, that makes sense. Okay, several particles have been emitted from the table. Okay, sure. Also, some of the newer resonances listed in the table. The antiparticle electron pairs would have been listed in the table, which would look exactly this one reflected with zero charge sum. Also, all the particles except for the electron, neutrino, photon, graviton, and photon are unstable. Decay products have been shown only for the resonance. Strangeness assignments are not applicable for leptons. Hey man, don't worry about it. Thank you for stopping by. I appreciate your time. It was great meeting you. What's your name? I'm from Romania. Alright, have a nice day, man. Appreciate your time. Alright. Well, it's gonna be for today. I think I'm already done with this. Oh, this table of interactions. Yep. Okay. Well, nice stream. Appreciate everybody's time here. It was good. Now I gotta head out. I have some stuff to do today. After that, I might start streaming some other things. Probably not studying. Probably gonna be some Tekken or piano practice or whatever. So, you know, if you like stopping by, make sure to say hi.